everyone, Mr. Voikin here. It's Unit 10, Lesson 1, last unit of this course. We're going to be looking at systems of linear equations. So basically what we're going to be doing is having an equation that has two variables and using two equations to solve for the x and y, or the two unknowns. So let's take a look at this first exploration right here. We got the Smith family and the Harper family, and they're going to a book fair, and Mr. Smith pays $11. Okay, so most of these are going to be word problems, so you're going to have to learn to pick out the important information. So Mr. Smith pays $11. Okay, well, what does he have? He's got 3 adults and 1 child. Then Mr. Harper or Mrs. Harper shows up, and she pays $12 with 2 adults and 3 children. So what we have to do is figure out what is the cost for an adult and what is the cost for a child. So if you notice right here, this is important. So you're saying let X be the adult cost and let Y be the child cost. So let's break down the equations that they came up with, which was 3x plus y equals 11. So that's going to be for Mr. Smith. Okay, so Mr. Smith paid, remember, x is the adult, and how many adults did Mr. Smith have? 3. And x is the cost of the adult. So 3 adults times x. So 3 times the cost is what he would have paid for the adults, plus he had some kids. And what were the kids represented by? Y. And how many kids did Mr. Smith have? He had 1. Okay, and then the constant right here is going to be the cost, the total cost of all the adult and child tickets together. Now, if we're going to graph this, it's not in the right format. I would want to minus 3x, and we end up with y equals negative 3x plus 11. Okay, now let's take a look at Mrs. Harper. So again, x represents the same thing. And we're going to be adding y, and it's going to equal whatever Miss Harper paid. So we know she paid 12, and she had 2 adults and 3 children. So we can just lay out the equation like that. And it's asking us to graph it. And then basically wherever the 2 lines intersect, that is going to give us an x and y coordinate for that point, the intersection point. And the x would be the value, the number of adults, and the y would be the number of children. So the x and y are going to have to turn out to be integer values and positive integer values, because we can't have negative people and we can't have a fraction of a person. Okay, so to graph this second one, we could either find the x and y intercepts, 2 points, and draw a line, or we can put it into the slope y-intercept form. So to put this into the slope y-intercept form, I would minus 2x from both sides, and then I would have to divide by 3 on this one. So I can sort of look at it and see what I want to do. I'm going to end up with y equals negative 2, and it's going to be divided by 3x. Plus the 12, which would be divided by 3, and 12 divided by 3 is 4. Okay, so I'm going to make this first line green. So I know I got a y-intercept at 11, and the slope is down 3, right 1. So I'm going to go down 3, right 1, down 3, right 1, down 3, right 1, down 3, right 1. And I will get a line that goes through all those points and would continue on forever in both directions. Now let's take a look at the second one. I'll use red for that one. It's got a y-intercept at 4, and it has a slope that is down 2, right 3. So down 2, right 3. And right away we land on that point from the other line, down 2, right 3, down 2, right 3. Okay, and that would form a line going straight through here, forever in both directions. And essentially this point right here that was at the intersection is going to be our x value of 3 and the y value of 2. So that tells us that the x is 3. What does x represent? It represents the adult tickets. So the adult ticket costs $3. And the y represents the child cost for the ticket. So the child cost for the ticket was $2. Okay, and that would be exactly what they're asking for in part B here. Okay. All right, so before we move down to the class example 1, I just want to go over a few points on this last example that we did right here. So we've got these two equations producing two different lines and a whole bunch of points, but there was one point in particular that we're interested in, and that is where they're intersecting. Because if I take the 3 for the x and substitute it in here, so I get 3 substituted with 3 plus 1, and the y value was 2. I get 3 times 3, which is 9, plus 2, which equals 11. So those 2 points make this equation true. Now, if I put it into the other equation down here, it should also be true. So 2 times x, which is 3, plus 3 times y, which is 2. I get 6 plus 6, which equals 12. And again, that is true. Now, basically, there are infinite points that will make this true. So if I go and grab this point right up here, which is 1 in the x and 8 in the y, and that's a point on the green line. So as long as I substitute those values back into the equation that we derived, it will also work out to be true. So x is 1, so 3 times 1 plus y, 1 times 8, does that equal 11? Well, 3 times 1 is 3, plus 8, that equals 11. That's true. And every other point on there would be true as well. Okay, and if I was to do that for the red line, then that would work out as well. So let's use the one here that's on the y-intercept. So that's a 0 for the x and a 4 for the y. And if I substitute those values in there, I'm just going to reduce the size of this a little bit, give myself some space. Okay, so if I substitute those values in there, x was 0, so 2 times 0 plus 3 times the y, which is 4, and does that equal 12? Well, 2 times 0 is 0, 3 times 4 is 12, and 12 equals 12, so it's right. So any one of those points will produce a true answer to that equation, but it's, again, only this one point right here where the two lines are intersecting that is important. So keeping that in mind, let's move down to our class example 1, and you can see that we do have two lines here. So it says that we want to use a system of equations, which is two equations, which will produce two lines, and the x and y values for the solution are going to be, again, where they cross, which is right here. So what is the x solution? Well, it is 2, and what is the y solution? It is -1. So it would just be put in a set of ordered pairs like that. All right, the class example 2, we've got two equations, so a system of equations. Both of them have an x and y variable. So we're being asked to solve for x and y that make both of these true at the same time. Remember, there's ultimate or infinite solutions for one, infinite solutions for the other, but if we combine the two together, in this case, there is only one solution, and that is where they cross, where they intersect. So it says to graph it without using technology. So again, I'm going to take my original equation, 2x plus y equals 2, and I'm going to put that into the slope y-intercept form. So I get y equals negative 2 over 1, x plus 2. And if I take the other one, which is x minus 3y equals 15, and if I put it into the slope y-intercept form, I get y equals 1 over 3x minus 5. Okay, so this first equation I'll do red, and the second equation I'll do green on the graph. So let's start with the red one. It's got a y-intercept at 2, and the line or the slope is telling me go down to right 1, down to right 1, down to right 1, etc. And I can go up to left 1, up to left 1, up to left 1, producing a line that goes through all those points approximately. And the green one has a y-intercept at negative 5, and the slope is telling us to go up 1 and right 3. So right there we actually land right on the other line. Up 1, right 3, and down 1, left 3, down 1, left 3, producing a line that goes through like that-ish. And there is our intersecting points, which happen to be at 1, 2, 3 in the x and negative 4 in the y. So that's part B. What is the solution to this? It is x with a value of 3 and y with a value of negative 4. It says algebraically verify. Okay, so verify just means prove. So I should be able to take the x value of 3 and the y value of negative 4 and put it into both those equations, and they should both end up being true. So I've got 2 times x plus y equals 2 on the first one, and the next one's going to be x minus 3 times y equals 15. And the x values are going to be 3. So wherever there was an x, I'm going to put a 3 in there, and wherever there was a y, I'll put a negative 4 in there. And you can just pump those into your calculator, but in this case, the math is pretty simple. It's 6 plus negative 4, which equals 2. So that is correct. And the next one is going to be 3 minus negative 12, which is really 3 plus 12, which is 15. And that one is correct also. Okay, on to class example number 3. Consider the equations from the beginning of the lesson. Rewrite each one of them in the slope y-intercept form. So the first one is going to be y equals negative 3x plus 11. And the second one will be y equals negative 2 over 3x plus 4. That should be correct. And now they're asking us to use a graphing calculator to check this. So I'll do this right on the one that's on screen. So go to the y equals, we'll clear any graphs that are already currently there. And we're just going to punch it in like we see it, which is negative 3x plus 11. And the second one is going to be, I need to turn them all on. One of those is on, I think that. Negative 2 over 3, so I want to get a fraction in here. I believe it's math. Fraction, things like that. So what's the top? A negative 2. So -2, and the bottom is a 3, and we have an x right there. So -2 over 3x plus 4. We'll go to our window. In this case, we are at -10. Now I noticed that my y-intercept on 1 was 11, so I'm definitely going to want to go up a little bit higher. So I'm going to go clear this, and I'll put -20, and we'll go up 20, we'll go down -20, and we'll go up, or to the right, sorry, or that is up 20, and we'll graph that. And it looks like I've turned them both off, so let's turn them both on and graph that. And there's our solution right there, where the two lines intersect. So if you can zoom in, you might be able to see exactly where it's crossing, but you don't really know until you do the math, or you use your calculator right here to find the intersection. So I think you go to calc, intersect. Oh, that was easy. And it says the solution is 3 in the x and 2 in the y. And this online calculator right here is a little different than the TI-84 you're using in class. To find that intersection, you're actually going to press the second function button and trace, which brings you into calc, and then you will choose the fifth option, which is intersection. But you should know how to do that already. The other thing we can do is if I close this, and I'd want to go to this table set up here. So I'm going to go second window, which I can say, where do I want the table to start and what do I want it to increment? So what do I want the x to increment by? So I'm going to start at 0, increment by 1, and you can put that on ask or auto. So I'm going to put it on auto right now, and then instead of graphing it, I'm going to hit second graph, which is going to bring up the table. And remember, the solution was this one right here, when x equals 3, and you can see both the other lines have the same value, which is 2. Okay, now if I was to go back here to the table set, I could go to the ask, and now when I go to the table, basically they're going to want us to input our ask, which was going to be 3 in the x, and when I hit enter, you can see up here it tells me that both of the y's are going to be 2. Okay, so class example 4, we've got two equations and it says solve using your calculator. So again, to do that, we need to put it into a format that can be input into the calculator. So if I take the first one, which is going to be 6a plus 7b equals 5, and we're going to say 6a equals negative 7b plus 5, and we're going to divide everything by 6, resulting with an a equals negative 7 over 6b plus 5 over 6. Okay, and the other one, which is 3a equals 14b, so I'm going to basically divide everything by 3, and I'll end up with a equals 14 over 3b, and really there's a plus 0 right there, but we're not going to include that. Now what I need to do is input that into my calculator. Okay, I brought the real calculator in here to go through this with you. So we're going to input the first one. So we're going to go to the y equals button, and now I need to put in a fraction, negative 7 over 6. So I'm just going to point with this, it's a little bit easier. So we're going to press the math button. Now what we want to do is get up to this part right here where it says fraction. So I can just hit the back arrow that brings me into there, and this first option is just a fraction with the numerator and denominator. Hit enter, and it now allows us to enter the fraction. So the numerator is going to be negative 7, not minus 7. Make sure you use this negative button down here. And if you press the down arrow, it brings you down to the bottom. The denominator is a 6. Now I need to move over, so I just use the arrow button right there, and it does say B, but we're just going to choose X, and then plus, and again we have another fraction, and so I'm going to go back to the math button, move to the left, select option 1, the numerator is 5, and the denominator is 6, and now I'll move down to the second equation, which is 14 over 3x, or b in that case. But again, math, move to the left, select the first option, the numerator is 14 and the denominator is 3, move over and press X. Okay, and now with my windows, I still have them set -20 and +20, scale of 1 on the X and Y. So if I hit graph, I should get those two lines. There's the first one, and there's the second one. So remember, what we're looking for here is where they intersect. So I could zoom in a lot more to get a better visual of where they're intersecting, but really I don't need to, because all I have to do is go second, trace, and we want number 5. And don't need to press enter. And now it says the first curve. So what they basically mean is first line in this case. So you can see if I just move to the left, I'm on the blue line, I press enter, and it automatically jumps down to the red line. So that is the second curve or second line. Press enter, and when it says guess, you just press enter again, and it goes to this intersection point. It says we have an X point of 0.1428 and a whole bunch of other decimals, and a Y of 0.666667. So you should recognize that the Y value is going to be 2 over 3 as a fraction, but the X value at this point is sort of the exact value is unknown. So we could put down those decimal values, but if we look at part B, it says to represent your answer as exact values. So that needs to be in some fractional form or radical form, no decimals. So luckily, the calculator actually stores that X value for us and stores the Y value for us. So once I have use this function to figure out the intersection point, it's recorded those and saved them. So now if I just hit clear twice, go back to this screen right here, and what I want to do is press this X button right here, and it says X, and then if I press enter, it tells me the value of X that was stored there. But again, it's in decimal form. So to convert that decimal to a fraction, you just press math, and number 1 says arrow fraction. So take whatever you have and move it into, or convert it into a fraction. So I'm just going to press 1 or enter. And it says, do you want to take that previous answer and convert it to a fraction? Say yes by pressing enter again. And it tells us that the value is going to be, so X equals 1 over 7. Okay, and what about the Y? What does it equal? Well, to figure out the Y, we're just going to go to the alpha and then 1. You can see it brings up a Y, and press enter. And same thing, it's going to give us the stored Y value as a decimal. And to convert that to a fraction, I just go math, 1, enter, and confirm, and it says that the Y is 2 over 3. Okay, so I'm just gonna bring that up like this, because the next thing it tells us to do is to verify this algebraically. Okay, so let's verify this algebraically. So we're gonna take the original equation, which is 6 times A plus 7 times B, and that equals 5. Now I've written down there actually X and Y because that's what was on the calculator. So we sort of want to go back to our original equations and just verify that we have the right values. So A is going to be our y, and b is going to be our x. Okay, so to substitute, it's 6 times a, which is 2 over 3, plus 7 times b, which is 1 over 7, and that should equal 5. So essentially, we've got the equals right here, so whatever's on the left side, it should equal whatever is on the right side. So let's just do the math to verify this. In this case right here, we got 6 times 2, which is 12, and 12 divided by 3 gives us 4, plus 7 times 1 is 7, and then divided by 7, 7 divided by 7 is 1, and is 4 plus 1 equal to 5, and the answer is yes. Okay, and just going to minimize this one really quickly, and we'll do the same thing with the second equation. Okay, so the second equation was a equals 14 over 3 times b, and I'm just going to substitute, so I end up with 2 over 3 equals 14 over 3 times b, which is 1 over 7. Just have to make this a little bit smaller so I can get space to move. Okay, and again, what we're trying to prove is that whatever is on the left side equals whatever is on the right side. So on the left side, we got 14 times 1, which is 14, over 3 times 7, 21. So I end up with 14 over 21. And if we reduce that down, we can see that 7 divides into 14 2 times, and 7 divides into 21 3 times, and we have 2 over 3 equals 2 over 3, so that one is also verified. Okay, that's it for this lesson. We'll see you in class. The assignment is on page 617, and the answers are right here on page 619.